In this video, I will be discussing the design and construction and the parts of the power meter shown in the following picture. Right, so now we need to obviously put this into a little case. So let's bring up all the bits and pieces that make up our actual device. I'm going to go through all the bits and pieces that I put together for this. All right, so there's basically all the components we're going to use, right? And I'll go through the buyer's guide now on AliExpress where I got most of the components. So this LCD display is just a 4-row 20-column character display, which uses a tiny little board at the bottom here, which takes I²C and basically then outputs whatever characters you write to it onto the LCD panel. We have an ESP32 Super Mini, and we have a level shifter. Now you will see other people use this ESPHome and they connect the ESP32 directly to it. I would not do that. Okay, this is a 5-volt device. The ESP32 is a 3.3 volt device. Some people claim that there's an undocumented feature that you can use 5 volts on some of the pins. It sounds like bullshit to me. So I chose to use a level shifter to put 3V 3 and convert it to 5 volt. And if the 5 volt signaling comes in, it will convert it to 3V 3. These are bidirectional. We'll do the wiring in the board onto this, the input wiring and the output wiring via these PG9 glands. So you basically slide the standard wire through, you bolt it down, and it holds the wire in place. So it's nice cable with tension relief and all that kind of stuff. This little block over here is the power supply unit. And then, of course, we've got a fuse to protect the circuit. Right. So let's look at what actually goes into this thing. So this is the circuit diagram. So the ESP32 C3 and our level shifter. We're going to use GPIO 8 and 9, which are our I²C bus. We're going to connect that to our LCD panel. And we're going to use GPIO 20 and 21 for the UART, and we're going to connect that to our power meter, the PSM. Okay, and I'll show you a little bit more about how this is connected, but basically you've got a high voltage and a low voltage side on your level shifter, and you take the 5 volt to the high voltage and the 3V 3 to the low voltage. So you can see that on whatever board you're using. I'm using this little guy, which is the ESP32 C3 Super Mini. I did a little mod to it to boost the power of the antenna, but I'll show you that in a second. And then, like I said, we're using pin 8 and 9 for I²C, pin 20 and 21 for RX and TX for the UART, and I use pin 2 for a push button. All right, so I got most of these components from AliExpress. So there is the PSM004T. This is the version 3. Just make sure that you've got a way of connecting to the TTL port. The nice thing about this one is it's also got a plastic case around it to keep the high voltage circuitry nicely out of finger locations, so that you don't actually touch that. In fact, I should just preface this video that if you're not comfortable with working with high voltage, don't attempt the project. I would say skip this one and look at something different to do. Anyway, so the data sheet of the PSM, which is available, this device is used all over the place. There's abundance of documentation. You can just get the data sheet for it. It'll show you how to wire it. Like I said, this JST connector over here, you'll need to be able to interface with that. So you can purchase them on AliExpress. There's, if you just search for the same thing, you would be able to find one that includes a little pre-made cable. So you'll just have to look. I unfortunately did not know at the time that the little cable would not be included. So Yeah, it's a bit of a tricky one. So just look out for one that will give you the little cable. So they range from a couple of yeah, I can't see, so it's tricky. You'll need to maybe contact the seller as well to determine if they sell it with the correct thing. This is the perf board that we're going to use to solder the components to. This over here is our PSU. So this is the RS Pro. Well, if you purchase from RS Components, it's actually listed as their own device as RS Pro range, but it's actually made by this company called Monsun. I have the LDE03-20B05, which is a 5 volt 600 milliamp output. And one little trick is you have to pull the data sheets down so you can look at these things to figure out what's going on with them. So when we go through all the limits and the safety and what have you, you'll get to the typical application. And you'll notice there's a C1 and C2 over here specifically, and they size them differently for the different boards. Oh, sorry, for the different PSUs, because they make a whole bunch of them, like 3 volt, 5 volt, 9 volt, 12, 15, and 24 volts. So because we got the 5 volt one, we want the 1 microfarad for C1, and we want a electrolytic capacitor of at least 150 microfarad for C2. I used 220 for C2, 220 microfarad, so 220 microfarad, and then a 1 microfarad polymer for C1. And then I put a couple of strategically placed decoupling capacitors, which were surface mount ceramics. And I just jotted them onto some of the pins just to help out with the noise. All right, so this is the level shifter I used. It's the 4-channel version. So just be careful, they come in two. There's a two-channel version and a 4-channel version. You want the 4-channel version if you're going to also connect the LCD. If you're not going to connect the LCD, go for a 2-channel version, then you don't have to worry about the extra pins. But they're cheap. They come in a pack of 10 for $3 Australian. Yeah, so it's based on the same one from Adafruit. So this is another one, bi-directional 4-channel level shifter, and it's pretty much exactly the same wiring. You've got your ground, obviously, you've got your high voltage, your low voltage, and your 4 data lines. Theirs is a little bit more pricey. Okay, this is the actual transistor arrangement for each of the 4 channels. It's just duplicated 4 times over. It's very interesting. You can see how interestingly the gate of the MOSFET is connected and how they use the body diode to do the bidirectional stuff. All right, then this is our ESP32, and I got them for even cheaper than this. So they'll cost you can get them as low as $1 US or $2 Australian. Just one little glitch, like I said, the antenna is not great, or the Wi-Fi is not great on them. To get a better signal, you can search for the ESP32 Super Mini Antenna modification, and that will show you how to do this little mod to get a substantial boost in signal quality. So this one would be the modded one, this would be the unmodified one, and if we look over here, you can see a rather big difference in improvement. Right, so let's get back to the FreeCAD. All right, so I'm going to hide the LCD panel, and then we'll take a look at how the case fits together. So we've got the base of the case there. I will bring in the rest of the stuff. Then I added some guides on the sides of the PSU to hold it from going sliding left and right. I added some guides to the PZEM. You'll see them sticking here on the edge. That stops it from sliding back left and right. And then I added some screw terminals next to each one of them. You see these little pillars that stand up at about the same level. The idea is I stick these little saddles on like that, and then I just strap them down. So now they're constrained on all 4 axes, left, right, up and down, but also squeezing it on the Z axis down onto the base plate so they don't move. I'm going to just hide the saddles while we go through the rest of it. Then where's the walls? screw pockets. Oh yeah, so I put some little places in for threaded inserts. Brought the walls up, so there we've got a case with walls now. And I punched some holes through the side of the case, so you can see them if I hide the glands. So I punched those little holes through the side there, and one for the fuse as well. And then I put at the bottom of the little board over here, the perf board, you'll see I put some little standoffs in there at the bottom, and those little standoffs for each one of the 4 screw terminals on it, or the little holes. And then what I found, the first version of the case, as soon as I started putting a bit of pressure on these little standoffs, they snapped off from the bottom. So I decided to add a bit of reinforcement. So I joined these 2 together. I made the other ones on the edges a little fatter, so that they would have a bit more plastic, and that seemed to fix that trick. Okay, so that's our case pretty much. Giving myself enough space over here to do the wiring and so on. And then for the lid, what I did there is I'll put the LCD panel back. So the lid is going to slide on top of that one. So let's take a look at the lid. I created first the base of the lid. So it's going to be, on top, and the LCD panel is just going to butt up against it. So then what I did is I added a little brim around, and I made the corners exaggerated so that there's no like pinching pressure on each of the 4 corners. So this would just slide neatly in there. And then I cut like 0.1 millimeter off the outer edge of this, so that it would actually fit into this and not like be really, really tight. Then on the top, I punched a little hole through for the LCD panel so we can see the text, and a little button hole for the backlight. So when you press the button, the backlight comes on. 20 seconds later, the backlight turns back off again. And oops, and then to obviously mount this guy, can't just float in mid-air. I added a couple of these little round pillars as well, and I punched some holes through them. Okay, so if I hide the case, you can see there that the little holes line up correctly, so that just screws in there. So I did these heated inserts, the threaded inserts that you install with a special solder tip into all of these devices. And yeah, that takes care of that. So I'll put the case back, and then these little saddles, like I said, they just also get screwed in and then hold everything in place. And that's our case. So I 3D printed this, and I'll now take you through that, or I may even put that in the second video. Right, excuse the mess on the desk, but it's one of those things. Here we've got the device printed up and assembled. We've got our output, we've got our input. You can see the 2 glands, the fuse holder. No, don't worry about that beep beep. And the device, I printed in white, big mistake. So a lot of little dirty marks already. Printed in a darker color if you do it. I'm going to open this on the side so I can show you inside. Right. These are little self-tapping screws, so I drilled a 3mm hole and then a smaller hole on the inside, and just had them tap themselves in there. Right, so there we got the display. I hot glued the push button to the top, and then there we've got the device. All right, so ESP32 level shifter, input capacitance for the power supply. This is the little power supply module. There's the PSIM, and I see that my connector has moved a little. Let me just give it a little bit of love. Right, so there's switch wires up here into this side. The power comes through here into this side of the board. I put in a couple of decoupling capacitors. I put one over here between the 5 volt and the 0 volt. And over here I put 2
I think it's 22, nope, what is it? Let me see. 2.2 microfarad ceramic caps right on the level shifter to decouple there. And I've also decoupled the switch so that if this wire picks up noise, the cap will just suppress that, because it's kind of a noisy circuit. You've got a switch mode here, you've got circuitry switching in there, you've got high voltage coming through there. All of this is incredibly noisy. So yeah, just a little bit of decoupling capacitance just to take care of issues. I have been noticing that the Wi-Fi has not been great. I think it's because of the amount of noise going on the board. So I'm glad that I got it to the edge, but it's still not as good as it could be. So may have to look at an external aerial that will screw onto the case side or something like that. But other than that, I can't complain. Circuit's working fine. I'll give you a demo. So if we put that back into place, we'll power up, plug that in, and fire that up. And depending on how, what timing we get, sometimes the voltage and what have you comes up instantaneously. Sometimes it takes a little time. I'm just going to power cycle it just to force it to come up quickly. It just depends on the boot sequence. It looks like we're going to have to wait. What I'll do is I'll fast forward the video past here until the display comes up. Right, so that was the auto dim feature. You saw that dimming. I push, it comes back on again for 20 seconds. I'll do the assembly while we wait. Oh, there we go. It's just come online. So it first gives me a bit of a false reading, like it's saying that we've got 1.1 kilowatt going through here. That is obviously incorrect. It will soon settle into a steady output, but we do have our voltage, 239 volt, 0.7 volts. Got our frequency. All right, see there, it's dropped 0, power consumption 0.7 watts. So that's the consumption of this device. I didn't think it would be that high. I think that might be a little bit of a false calculation. It settles in at about 0.6 watts or so after a little while. But anyway, there's our device. I'm going to go stick this into the kitchen, onto the fridge, and I'll catch you on the other side of this video.
All right, let's look at the device in Home Assistant. Here we are, Power Meter 2. There was a Power Meter 1, which was an older design. I'm guessing there will be a Power Meter 3, 4, 5, 6 going over the years as I improve it. The device has been running for quite a while. My data cuts off after about 30 days or so, so it's only got the last month's worth of data. It's connected to my fridge. I wanted to know why there's a noise in my kitchen. I thought the fridge was running, but it turns out it was actually this internet box. It's a very bad name for enclosure for all my internet devices, my firewall and all that kind of stuff. And it has a fan that is PWM controlled, and it's currently running it at 100% duty cycle. And that's where the noise actually came from. But now I have good data about my fridge. So if we click through to this, we can see nice clean data coming through. We can even go and look a little bit over, like say, let's look over a week. We can see all the data come through quite nicely. And this is specifically the power. I can look at current and all that kind of stuff as well. But yeah, it's been running stably. Like I said, when we were looking at it, it was about 1 kilowatt hour that was going through it. It's up to 47 at the moment. As you can see, the power factor is pretty atrocious. It's where's the power factor? 0.65. So it's probably either a capacitive or an inductive load, probably inductive because it's a motor that pumps. But you can see it's mostly 100 watts, 50 watts, or then 250 watts if the fridge was open for a long time. And yeah, that's pretty much all I need to report. The one trick though is, like I said, I had terrible stability in the signal, and that was because of the transmit power. I'll show you how to fix that now. You'll see here my signal strength on my Starlink is minus 27 dB. So yeah, it's pretty good. I was not getting anywhere near this without the antenna mod. So the antenna mod actually improved it so much that I had to turn down the transmit power. All right, so the way that I did that is, let me show you. So this is the ESPHome config for it. You use that little board specification over there. And I've X'd out all the sensitive stuff on my network, but the key here is improve Wi-Fi stability. So I literally had to turn the transmit power down to 8.5 dB from 20 to get it to run stable. And this is literally all I had to do to like finally get this to like a 5-star rating in stability. Is just that little bit. Okay, and the rest of it's pretty self-explanatory. You can get AI to kick you out a config like this, but I may just put this on GitHub, and then I will just update the video description to keep us to get a link to GitHub. You'll see there's the voltage, there's the current, there's the power. So it keeps all these settings individually, and it accesses them from a specific address from the Modbus. And then this is the button logic for the switch and so on, the little script that turns it off after 20 seconds. And then this is our display over here. So if there is no data display, it just shows dashes. And then if there is data, it will fill in the rest of it. Well, thank you very much for watching.